The concept of time travel has captivated the human imagination for centuries. From ancient myths to modern science fiction, the idea of journeying through time has been a source of endless fascination. We yearn to witness pivotal events, right historical wrongs, or catch a glimpse of the future. But is time travel truly possible? Could we one day build a machine that allows us to navigate the rivers of time? While the practicalities remain firmly in the realm of science fiction, the theoretical possibility of time travel is a topic that has intrigued physicists for decades. Albert Einstein's theory of relativity, published in the early 20th century, provided the first scientific framework for understanding time as a malleable dimension. Einstein's work suggested that time is not absolute, but rather relative, dependent on the observer's frame of reference. This revolutionary concept opened the door to the possibility of manipulating time itself. In this exploration of time travel, we will delve into the mind-bending world of Einstein's relativity, exploring concepts like time dilation and the potential of black holes and wormholes as gateways through time. We will grapple with the paradoxes that time travel presents, such as the infamous grandfather paradox, and consider potential solutions offered by theories like the multiverse. Join us as we embark on a journey through time, exploring the science and speculation surrounding this captivating concept. One of the most startling revelations of Einstein's theory of relativity is that time is not constant. It is not a universal metronome ticking at the same rate for everyone, everywhere. Instead, time is relative, its passage dependent on factors like speed and gravity. This phenomenon, known as time dilation, is one of the cornerstones of time travel theory. Imagine two identical clocks, perfectly synchronized. One clock remains on Earth, while the other embarks on a high-speed journey aboard a spacecraft. According to Einstein's theory, the clock on the speeding spacecraft will tick slightly slower than the clock on Earth. This difference in timekeeping, though minute at everyday speeds, becomes increasingly pronounced as the spacecraft approaches the speed of light. This concept, while counterintuitive, has been experimentally verified. Atomic clocks, accurate to within a fraction of a second over millennia, have been flown on high-speed jets. Upon their return, these clocks were found to be ever so slightly behind their Earthbound counterparts, confirming Einstein's predictions. Time dilation suggests that time is not a rigid, unyielding framework, but rather a fluid dimension, influenced by motion. The faster one travels, the slower time passes relative to a stationary observer. This concept, while seemingly bizarre, is fundamental to our understanding of the universe and underpins much of the theoretical framework surrounding time travel. Black holes, those enigmatic cosmic objects with gravitational pulls so intense that not even light can escape, have long captured the imagination as potential gateways for time travel, sparking countless theories and science fiction stories. These celestial behemoths warp the fabric of space-time around them, creating a gravitational well so deep that the laws of physics as we know them break down, leading to fascinating possibilities. According to Einstein's theory of general relativity, gravity is not a force, but rather a curvature in the fabric of space-time caused by the presence of mass and energy, fundamentally altering our understanding of the universe. Massive objects like stars and planets create a dent in this fabric, much like a bowling ball placed on a trampoline, illustrating how gravity works in a more intuitive way. Black holes, with their immense density, create an infinitely deep gravitational well in space-time, leading to a singularity where conventional physics no longer applies. As one approaches a black hole, time slows down dramatically due to the intense gravity, a phenomenon known as time dilation. From the perspective of an observer far away, an object falling into a black hole would appear to slow down as it approached the event horizon, the point of no return, eventually freezing in time, creating a surreal visual effect. However, from the perspective of the object itself, time would continue to flow normally, albeit experiencing the universe at an accelerated rate, making the journey even more intriguing. Theoretically, if one could survive the crushing gravity and intense radiation near a black hole, it might be possible to use this time-warping effect to travel into the future, opening up new frontiers in space exploration. However, the practical challenges of such a feat are insurmountable with our current technology and understanding, requiring advancements far beyond our current capabilities. Section 4. Wormholes, shortcuts through space and time. Wormholes, also known as Einstein-Rosen bridges, offer another tantalizing possibility for time travel. These hypothetical tunnels through the fabric of space-time could potentially connect two distant points in the universe, or even different points in time. Imagine space-time as a sheet of paper, folded in half. A wormhole would be like a hole punched through both layers of the paper, creating a shortcut between two otherwise distant points. While there is no observational evidence to confirm the existence of wormholes, they are theoretically permissible within the framework of Einstein's general relativity. If wormholes do exist, they could potentially be manipulated to create a closed time-like curve, a path through space-time that loops back on itself, allowing for travel through time. However, the creation and stabilization of a wormhole would require exotic matter with negative mass energy density, a substance currently unknown to science. Despite the significant theoretical challenges, the concept of wormholes as potential time portals continues to intrigue physicists and science fiction writers alike. While their existence remains purely hypothetical, the possibility of these cosmic shortcuts continues to fuel our dreams of conquering the vastness of space and time. Section 5. The Grandfather Paradox, a time traveler's nightmare. The prospect of time travel, while exhilarating, is fraught with logical inconsistencies and paradoxes that challenge our understanding of causality and the nature of time itself. The very idea of moving through time, whether forward or backward, opens up a Pandora's box of theoretical dilemmas. Perhaps the most famous of these is the Grandfather Paradox, a thought experiment that highlights the potential contradictions inherent in backward time travel. This paradox has been a staple in discussions about the feasibility and implications of altering the past. Imagine a time traveler venturing into the past, and through a series of unfortunate events causing the death of their own grandfather before their parent was even born. This scenario, while seemingly far-fetched, serves to illustrate the complex web of cause and effect. This seemingly innocuous act creates a paradox. If the time traveler's grandfather died before conceiving their parent, the time traveler themselves could never have been born. The very existence of the time traveler becomes an enigma. But if the time traveler was never born, how could they have traveled back in time to kill their grandfather in the first place? This question leads us into a loop of logical contradictions. The grandfather paradox highlights the potential for causal loops and inconsistencies that arise when considering time travel to the past. These loops can create scenarios where cause and effect become entangled in ways that defy our conventional understanding. It suggests that any action taken in the past, no matter how insignificant, has the potential to unravel the fabric of reality as we know it. The consequences of such actions could be far-reaching and unpredictable. While the grandfather paradox is a thought experiment, it raises profound questions about the nature of time, free will, and the limits of our understanding of the universe. It challenges us to reconsider the very foundations of our reality. It has led physicists and philosophers to propose various solutions, including the possibility of self-consistent timelines, alternate universes, or fundamental limitations on our ability to alter the past. Each of these solutions offers a different perspective on the intricate dance between time and existence. Section 6. Many worlds, many possibilities, the multiverse theory. The multiverse theory, a concept that has gained significant traction in recent years, offers a potential solution to the paradoxes inherent in time travel. This theory has intrigued scientists and enthusiasts alike, sparking debates and discussions across various fields. This theory proposes that our universe is just one of many, perhaps an infinite number, of universes coexisting within a vast, interconnected multiverse. Each of these universes could have different laws of physics, different histories, and different outcomes. In this view, each universe represents a different set of initial conditions or a different branch of quantum possibilities. These branches are like the many paths a river can take, each leading to a unique destination. Every time a decision is made, every time a quantum measurement is taken, the universe splits, creating new timelines and new possibilities. This means that every choice, no matter how small, can lead to the creation of a new universe. Within this framework, time travel to the past wouldn't actually alter the past of one's own universe, but would instead transport the traveler to a different, parallel universe with a similar but slightly different history. This idea challenges our traditional understanding of time and causality. Imagine returning to the grandfather paradox. This classic thought experiment raises questions about the nature of time and existence. In the multiverse model, killing one's grandfather in the past wouldn't erase oneself from existence, but would instead create a new timeline, a new universe where the grandfather never existed, and the traveler originated from a different branch of reality. This new universe would continue to evolve independently. This interpretation allows for time travel to the past without violating causality or creating paradoxes. It provides a framework where the rules of cause and effect remain intact, even in the face of seemingly impossible scenarios. While the multiverse theory remains speculative, it is a fascinating concept that resonates with physicists and cosmologists, grappling with the implications of quantum mechanics and the nature of reality. It challenges us to think beyond our conventional understanding of the universe. It offers a glimpse into a universe far stranger and more complex than we ever imagined, where the possibilities are truly endless. The multiverse theory invites us to explore the unknown and consider the infinite potential that lies beyond our own universe.